Hello, welcome to Sri Lanka DevOps community. Today we are going to discuss about Redis on AKS. We are going to explore how to set up Redis cluster on AKS for high availability, and then how to set up a Redis standalone deployment so that we can do local development and debugging with .NET applications. With that, let's move on and identify what is Redis cluster. A Redis cluster deployed with Bitnami Redis would be something like as shown here, where you can have multiple master nodes and multiple slave nodes for each master, and you can even have each master to have multiple slaves as well in the Redis cluster deployment mode, and you can even increase the number of masters that you have. But this mode only allows access within AKS for the Redis environment. But to do local development, you need access outside AKS environment. For that purpose, you can deploy it as in standalone mode so that you can get the access to local environment where you can do the development and easily work with it for the development purpose. And in your QA and other production environments, you can deploy it as Redis cluster mode, and then you can use it for real processing inside AKS cluster. So your application containers can communicate with Redis internally inside the AKS cluster. So without delaying further, let's move on to demonstrations on how to deploy and how to use this. So I'll move on to my Visual Studio Code window. Okay, here I'm going to explain a few things to you. Before I started this, I actually created two custom Docker files, that is a Redis cluster Docker file and a Redis standalone Docker file. Why I need custom ones, I will explain shortly. So Redis actually with 8 version of it comes with JSON module and several other modules which are useful for us to use. But these modules by default available in Redis 8.02. However, Bitnami Redis, where the Docker image is this one, as you can see, it's Bitnami Redis cluster 802 Debian 12R2, does not include the Redis modules. It is if it is provided as a service, it comes with licensing issues, so that's why it is not available as this. But what we can do is we can use the Redis 802 image and copy over the Redis modules from that image and extract them and put them into Bitnami Redis cluster 802. So when we do that, we can build a custom image, and we have to set the user accordingly. By the Redis cluster, they are using the user as not root user, so we have to set it back to 1001 user. So when we do that, actually this particular custom image is available with your JSON module and other modules. So what are the modules that I'm using, I'll show you later on. But in the standalone mode also, we have to have a different Bitnami Redis Docker image. So because of that, we have to create another custom image. Again, using the same principle, we are copying JSON module and other modules from 802 Bitnami 802 Redis official image into the Bitnami Redis image. So doing that is totally fine, because we are, even if you use in a commercial SaaS product, that should be fine, because the licensing terms does not is not going to be violated unless and otherwise you are going to provide Redis as a service outside to your customers from your SaaS application. If you are using it for internal purpose within your SaaS application and use it, it is not a license violation. But if you are providing Redis as a service, that would be a licensing violation. So be careful about the licensing when you are doing this. Ensure you are using Redis inside your commercial SaaS application only for the purpose of internal purposes, but not expose Redis as a service to outside customers. If you are doing so, you have to open source your your production commercial SaaS application, you have to open source if you are doing so according to the licensing. Otherwise, you can keep your SaaS application as a private source, but you can use Redis inside your application without having licensing issues. Okay, that's about licensing, but let's move on. So what I have done is I have created these two Docker images and then pushed them into my container registry. So I'll show you my container registry so that you can find out that. So let me try to get the container registries maybe. Here you can see I have a demo shared container registry. So in that demo shared container registry, if I go to repositories, you can see I have created the custom Redis, and then I have Bitnami Redis cluster, and then I have Bitnami Redis standalone. So I'm going to use these two images with Helm deployment to deploy the Redis cluster in my AKS environment. So if I go and show you, I have a tag called 1.0. For here also I have a tag called 1.0. I have deployed AKS cluster where there is two node pools, Windows and Linux node pool, but we are using Linux node pool only for the purpose of Redis deployment. Windows node pool is as a test, but you don't need to consider about it. So as of now, I have nothing deployed here, nothing much, but RabbitMQ cluster is deployed, so you don't need to worry about those things. But we can go and explore what is in the AKS cluster by doing we can do a clear screen, and I can do a kubectl get namespaces to show you what are the namespaces I have. So you can see there are several namespaces. So one thing that is important is I have deployed something called Cert Manager, which is actually internal certificate management tool that can be used inside Kubernetes. So how to deploy that, I'll just quickly show you. It is pretty easy. So you can actually get this YAML deployment file from GitHub repo of the Cert Manager official GitHub repo, and I have deployed the latest version v18.1. So I use it inside my repository just because I need to add additional things into deployment. That is just one modification only. I need to ensure it is actually getting scheduled into Linux node. So I add node selector Kubernetes iOS Linux. So this is the only part that I have added to the official deployment YAML of this Cert Manager to ensure, since I have Windows nodes as well, I have to ensure it is getting scheduled in Linux nodes. So as you can see here in my AKS cluster, if I see kubectl get all namespace Cert Manager, then you should be able to see I have Cert Manager running fine. So this should be a prerequisite before we deploy AKS. So you should have Cert Manager, webhook, etc. in operational mode. So this is all running now after I have done deployment. To do this deployment, what I use is like I can do a I'll show you the Cert Manager. So what I do is I deploy this manifest and I have implemented my own health check. Probably I will blog about this later on, so you can read through it. So this is how I deploy the YAML, and then once I deploy it, I wait for some time for it to be operational. So that's how it is set up. So let's go to our main focus, that is Redis cluster deployment. So before I deploy Redis cluster, I have a couple of prerequisites that I need to set up. So that is, I have created a YAML file, YAML deployment manifest with that information. So you can see here, I have something called Bitnami Redis cluster prerequisites. So in here, I'll explain what it is. So since we are doing this in Azure environment, we have to have a storage class defined. Otherwise, we can use default disk Azure storage, but that will be actually creating a maybe zone redundant storage. So you may not want to do that when you are doing actual implementation. So if you want to have SSD local redundant storage, that should be fine for this Redis deployment, because it would be always temporary data that you are storing here, and you need to set files fs type into ext4 to ensure it is properly supported with Redis usage. So because of that, you need to create this storage custom class. So you can do this using this code segment. Later on I will be blogging about all these things, so you will be able to find out all the source code available in my blogs in the coming month. So this is how the storage class is defined, and then we need to define a secret for keeping the password of the Redis cluster. So I have temporarily added a password as my Redis password. This is bad practice. What you can really do is you can have a token here and then get your pipeline to replace this token. So what you can do is you can maybe use something like Terraform to generate a random password for you, like using something like this. So you can see here I can generate a Redis password with complexity I want. So that can be then output from Redis, and then using the pipeline you can replace this particular Bitnami Redis cluster secret variable here, and then you can use it in practical terms. But for this demo purpose, I have just comment out the token, and then I have used a hard-coded password here. So that's totally fine. And since we need to set up a separate way of having a dev environment, so even though when we are having the realistic situation, we will be only having dev environment in dev environment, but in your cluster mode deployment in all other environments. But here for this demo purpose, I am using the same AKS cluster. So I am going to use two namespaces just to demonstrate it to you. So this is simulating a QA kind of situation, QA production kind of situation with a Redis cluster, and where there is a Redis dev namespace where I will show you and simulate it to you a dev environment setup, how it should work. So for that purpose, I will create two namespaces. One is Redis, that is simulating the production, and then simulating the dev environment, I will create Redis dev inside the same AKS cluster. But in general, you will be having one namespace called Redis, and you will be deploying standalone mode into your dev environment, and from QA environment onwards to the production, you will be deploying Redis in the cluster mode. So you don't have to have two, but you can have only one Redis credential definition with a secret, Kubernetes secret. Okay, that is about prerequisites. So let's get this prerequisite deployed. So since I have not created the namespace here, I'll manually create it for now. But I have a separate system prerequisites. If you see here, like you can see, it's actually creating the Redis namespace here. So when you are doing a pipeline setup, you can actually organize your pipeline flow in such an order, so you can get all those things created. Probably I will explain later in a blog post about all these pipeline stuff that you want to learn. But let's focus on getting Redis demo done here. So before anything else, I can actually create the namespace from here as well. So kubectl create namespace Redis, and then I'll create the Redis dev namespace as well. So I have opened the same WSL window within Visual Studio Code here. So if I go and see here the namespaces now, I should have two additional namespaces created a few seconds ago. Okay, let's get start deployment of the Helm chart. So before I go into much detail, you can actually go into this particular Helm chart very easily. So I might quickly get that for you and show you where you can find it. So I have something called Kubernetes here, then I have a bookmark here. So I will show you the Redis cluster probably. So there is a GitHub repo called Bitnami charts, where you can find a folder called Redis cluster, and then there's a Redis folder for standalone. So this is Redis cluster deployment. So you can find that same image that I have shown you. So this is copied from here, and it has all the documentation and details, and you can find how to add custom parameters, etc. So there's all the details you need. And similarly for the Redis also, you have the same, like Redis is standalone also, you should have the same information in this URL. So this is actually standalone mode. So you have all the parameter information here for the standalone mode, like master and replica information. So here you need to define so many things. Okay, without going into all the details of that one, I will explain you the most important ones here. So first thing is, like, you need to do a Helm upgrade Redis cluster, bitnami Redis cluster install, and then when you are doing it, you can do it to your own namespace called Redis, and then you can use your version of the chart. To find out the versions, what you can do is, like, you can actually first do this kind of Helm repo add bitnami add. So probably I'll show you that part as well, so that you can understand what we are doing, we need to do from the beginning. So you can see it's already exists because I have done already that part. And then we can do a Helm repo update so that everything gets updated properly. So you can see it's getting updated. So I will talk about this OT Helm later on, but you can see that is there. And then to find out what are the latest versions of Redis cluster, what we can do is we can go here and execute Helm search repo, and then you have to specify the repo name and say -- versions. When you do that, you will find out what are the versions available for this particular and bitnami Redis cluster, where the latest version is 12.0.10, and you can see it is coming with 8.02 Redis version. So what I am using here as the version is 12.0.10. So that should be good enough. And then we can specify a node selector. You specifically need this if you have Windows pools as well. Otherwise you can just skip this. But it is better to always have it, so that later on if you added a Windows node pool, these Redis nodes will not get scheduled into Windows. So then you can set affinity rules. That is actually, you are trying to make sure your pods are getting allocated in a soft principle. That is actually you allow the same multiple pods get scheduled into the same node in AKS, but you can specify a hard affinity rule, or you can specify your own affinity rule, so that you can even ensure each Redis cluster node is getting allocated. Actually, Redis cluster node will be a pod, so that pod can be getting allocated into a particular zone node kind of thing. So you can actually read through documentation and make your own decision about how you want to do this. But I probably will have soft here, or even I can have hard, but I don't mind for this demo purpose having a secondary node or secondary master running in the same AKS node pool node. So that's why I put it as soft for the demonstration purpose. But in real production situation, you might want to change this to hard, or you need to define your own custom affinity rules using the parameters defined in Helm chart, where you can find the details in the documentation I have shown you previously. And then you can actually define the default storage class. This is the storage class that we have defined in here. You can see the name of it, that is Redis storage, and we are going to use that Redis storage class. Okay, and then we can say the policy of persistent volume and when to delete. If we are removing Redis, we can remove the persistent volumes and then delete the disk storages that are getting created in Kubernetes, so that we save the cost. So that is why these parameters are set up in this way. And then I set up the service credential and password here. You can see Redis service credentials is used and the password is used, and it should exist in the same namespace as where you deploy the Redis cluster. So you can see here I have deployed the secret here in the Redis namespace and in Redis dev, but we are using this one for the cluster deployment here. So that is that. And then I have a Redis extra flag setup. So this is to make sure my Bitnami Redis image is getting loaded with the JSON and other modules that I have copied from Redis 8.0 version. So I have shown you a Docker file where I copied the modules, but to load the modules, I need to set up this extra environment variable called Redis extra flags. And then I have to provide this information to load the module. So you can see here I am loading the JSON module as well. And then I can set up the number of nodes and number of replicas I want. And then I can actually go to set up this persistent size. So this is the disk size that I am specifying. So for this one, actually in production situation, maybe you might want to use 8 GI or something, or 16 GI. But for the purpose of this demonstration, I'm creating only 1 GI because to save the cost, because I don't want to spend a lot of money on demonstration purposes. So again, memory and CPU, you might need to consider higher values for like something like 4 GI maybe, and 1 CPU maybe as a request. It is a good practice to not to specify a limit for CPU, but specify limit and memory, limit and request in the same value for memory to avoid OOM kills as much as possible. So you might need higher memory for actual production situations such as 8 GI or 4 GI, but for this demonstration purpose, 1 GI is more than enough. So we can continue like so the security allow in insecure images true is set because we are using a custom image. Now you can see here I am using the custom image that I have created, ch custom Redis, ch bitnami Redis cluster, and the tag with 1.0. So this setting it to true is required, and you can see here I have specified my registry as chdemo shared ACR Azure IO. So this is required to load the custom image. Now if I again show you the custom image that we are going to use in the cluster, it would be this. It is nothing much, no magic. It's just actually copying 802 Redis official image modules into the Bitnami Redis cluster, and we can use it. Actually, we can't directly use Redis image because it doesn't have the implementation of cluster mode. Cluster mode implementation is included only in Redis cluster image by Bitnami. So that is why we need to use modules only and copy them over to the Bitnami Redis. So that's why I'm using a custom image. Okay, that's all the information about that. So let's quickly go and try to deploy this. But now since this is PowerShell mode, I have a escape like this. But for Linux kind of escape is little bit different. So I'll copy this to a notepad, and what I will have to do is do a replace here. So I'll do a replace into \, and then go and copy the entire thing, and then I'm going to clear screen here and paste this here. Now when I press enter, it will start deployment of this Helm chart. Now as you can see here, you can see that this cluster does not exist, so it's installing it now. So it will finish like this in couple of seconds, but it's not 100% finished yet. So we can go kubectl get all, and we can give the namespace Redis and see what is there. So you can see the container is getting created, and we can go ahead and check this further, whether this is getting created from the AKS point of view. So we can go here and check AKS cluster. So if we go to storage, we should be able to see in the Redis namespace there's storages are getting created, So you can see 1 GI storages are getting created, and then eventually the workloads will come up here. So we'll go here and inspect it again. So you can see it is waiting still at the container creating stage. We will give it a few seconds and it should be done. Let's retry again. It's not creating yet, so there might be a mistake we have made. I think I made a mistake because I have not deployed the prerequisites, that is Bitnami Redis cluster prerequisites. I think I didn't deploy this properly, so probably I don't have certain things running here. Okay, yeah, if I go to here into Redis cluster and in check events, you can see it is not possible to load the Redis password because I have not created it. We can confirm that. We can go to configuration and we can go to secrets and see if we have the Redis credentials. No, so that means actually we have missed one step. We created the namespace, but we didn't deploy the prerequisites. So the best thing that we can do right now is like let's go ahead and uninstall this Helm. So I'll go and do that. So this is good learning in a demo. This is why we need to create this in a pipeline mode, so that things get actually properly run in order, so you are not missing certain steps. So I have uninstalled now, so you can see if I check get all, there's no resources available here. And let's go and see if the storages are getting cleaned up in Redis namespace. Yes, that is getting cleaned up. So you can see there's no storage for Redis anymore. So no volumes for Redis. So there's nothing. So it's fully cleaned up. So let's begin again. So what I will do is I will ensure I'm deploying this Bitnami Redis cluster prerequisites first. Before, now I have clean namespaces again. And then with the namespace, I will deploy this additional storage class and the secrets. To do that, I will do kubectl apply. So you can actually make all these things into a pipeline and deploy it properly. As for an example, like you can have steps like this. You can see kubectl apply and apply prerequisite manifest. So like that, you can actually do it in a pipeline using a single script so that you won't miss steps like this. But it's better to show in a demonstration step by step so that you can learn all the steps along. So let me try to deploy the Bitnami Redis cluster prerequisites YAML. So when I do that, you can see storage class is getting created and then the Redis service getting created with this additional stuff. So I did that now, and then I can go and inspect the storage. Should be not there, but we can go and check if the storage class is there. You can see Redis storage class is there now. And then we can go to configuration and secrets and see, refresh and see. You can see a Redis service credential has got created, and even Redis dev, we should have a Redis service credential created. And if you go inside this one, you can actually view the password if you want. By clicking here, you can see it is created with my Redis password. Okay, that's good enough. So let's go back to the Helm deployment again. So I will copy the same Helm deployment file again, and then I will retry deploying it. So I'll clear the screen to make it more visible, and then let's deploy it again. So this time it should start creating the containers faster, because now I have all the credentials etc set up. So let's give it a moment, and then let's see we can get all Redis resources. So it started container creating. Let's give a few seconds and see. So in the meantime, we can go and discuss about the local development mode YAML until this is getting deployed. So for the local development purpose, as I said, like when you have multiple master nodes, you can't access it from local environment outside Kubernetes. Actually, you can't access it outside the Kubernetes environment. So in that kind of a situation, what we can do is we can actually go ahead and deploy a standalone mode. Now again, there's nothing much changed, like it's actually another Helm repo, and what we are using for this purpose would be instead of using the Bitnami Redis cluster image, here you are using Bitnami Redis image 802. Again, this is by default not including the modules that we have, so we have to copy over the modules and create a custom image and use that custom image. So here you can see the custom image details I have specified here. I'm not going to explain all these things because I have previously explained, but there's a slight difference how you load modules in this one. So you have to say set master extra flags here and set replica extra flags here and provide the module information like this. So I'll share later in the blog post all this information so that you can go ahead and set it up like that. And then you can see I'm using the Redis credentials dev here, and then I'm using the password, and you can see let's see and double confirm whether we have Redis credential dev created here. Yes, that is true. And if we go and check the namespace, yes, Redis credential dev is there. Now we can go back and check if our containers are ready by now. Okay, still it's getting created. You can see there's a couple of restarts happen. That is explainable because while this is happening, it is actually waiting for other nodes to be available. So that's why there's a couple of restarts happen. So, but some of them have not even needed a restart. But I'll go and show you the inside of this one, what happened when it is actually booted up. So let me show you kubectl logs here, and then go to this one and say in Redis. So you will see some interesting information. You can see this is actually deploying in the cluster mode, and you can see this is all built into the Bitnami image, and you can see the Redis version running is 802, and you can see our custom modules are getting loaded here. You can see it is loading the Redis Bloom module, and then we can see the Redis time series module is getting loaded and the JSON module getting loaded, and it is waiting for cluster mode to be ready and communicate with the other cluster nodes. And then if you go and inspect something like the replica one, you can go and see what is there. You can see it is having a slightly different log, and it is connecting part of a cluster. It's working as part of cluster, and it's actually changing master slave configurations accordingly and setting it up. So each one is behaving in a different way here. So if we want to check what are the masters and in this cluster, if you want to check what are the masters and what are the slaves, what we can do is we can quickly execute a command. So I have copied those commands for easy checking those things. So we can go ahead and see what are they. So we can go ahead and see information about the replication. So we can go ahead and execute this particular command. So which says I'm going to execute a Redis CLI command here, and then I provide my authentication information here, and I'm asking for info of the replication. So I'm doing this for Redis cluster node 0. So you can see there's about 6 nodes here. So I'm first executing this to the node 0. So when I do that, you will be okay. Let me enter here, and then when I do that, you can see it's a master one. And if I do it for 1, it could be a master. Yeah, it is a master. And then if I do it for the second one, probably it's a master as well, but from third one onward it will be slaves. So we have 3 masters and 3 slaves. So you can see it's a slave. So likewise, even if I do it for the 5th one, that is the 6th one, number 5 index, so you should be seeing it as slave. So that is the cluster setup. So we already have the cluster setup working here. Now to access and work with this deployed one, we can use another tool called Redis Insights. Again, Redis Insights is free to use as long as you are not exposing this Redis Insight outside of your organization. Even for a commercial product, you can use Redis Insight for weaving insights of the Redis cluster that is deployed for internal organization perspective, even for a commercial product. But you can't expose it to your customers as a service. If you expose it as a customer to your customers as a service, there'll be a licensing issue coming up. So you have to carefully evaluate the licensing. Don't take my word for it. Just go and evaluate yourself all the licensing terms and legal terms before you use it. So that is how you should be doing it in a real organization environment. But what I have learned so far is that it is possible for you to use free without paying anything, as long as you're not exposing it to the customers, even in a commercial products. But just verify all the licensing by your legal teams before you use it. So let's go and try to identify how to deploy Redis Insight. So to deploy Redis Insight, what you can do is like you can use something. Again, you have to have a persistent volume and using the same storage class with 1 GI. I'm setting up for the demo purpose. You can increase it for the production needs, but you can do a deployment of type name Redis Insight, and then you can actually, you need this BusyBox implementation to ensure you are enabling the data access to this root user, that is 1000 root user. So you need to allow that. So you need this specific part to enable it to work with AKS. Otherwise the mounted volume will not work, and this Redis image, Redis Insight image will not work. So you can find out all these latest Redis Insight images list. So you can look for Redis Insight image in Docker repo. So you can go and search for Redis Insight official image or something like that in Google. So let me try to do that for you and show you, official Docker image, and you should find it here, and you can find the latest version, etc., and all the licensing information, etc., should be here. So you can go ahead and like go to their GitHub repo and find out the licensing, whether you can use it or not. All these things you can find out from there onward. But we are using it for this demo definitely, and we are using the 270 IMD64 image, probably the latest image I think I am using. 270 is the latest version as of now. So I'm using that image and getting Redis Insight deployed. And here what I am doing is I'm attaching my Redis cluster to this one, and you can see I use 0 to ensure the Redis cluster, and then I attach standalone mode. Even though I don't have it yet, I'm attaching it just to ensure that it's available when it is ready. So we can deploy it later on and see how it goes, but for now we can just have this Redis Insight deployed. So, and to access Redis Insight from outside, I'm using a full load balancer, and I'm accessing it outside the Redis AKS cluster. But I urge you to not to do this in this way using a public IP, where you might accidentally expose it to your clients or customers, and which might incur licensing issues. So it's better if you could make it a private IP, and then ensure it's internal access only using your VNet, and then maybe you can create a VPN for your organization, so that you can actually access it only via the VPN connectivity, so that your organization employees are only accessing the Redis Insight, not the outside public. But for the demo purpose, I'm using a public IP, no problem, and my source code is also open source for this demo, so using it for this purpose is totally fine, because as long as you are open sourcing your source code, you can actually use it with the public access, no problems. So let's deploy that as well here. So I will deploy Redis Insights YAML here, and when I do that, you can see several things get created and a load balance also get created. So if I go and look at my namespace again, I should see a container is getting created, and you can see my init container is running now, and then afterwards it should create the container should be ready in few seconds. Now you can see pod is initializing. It should be ready within few more seconds. Yeah, you can see it is running and my load balancer is ready, and my load balancer IP is allocated, and I have actually pre-created these IPs using Terraform. So, and I have enabled them with the special routing setup. So you can go ahead and see my, let me show you how I have set it up. So I have set it up within this, and you have to ensure this public IPs get set up within your AKS special resource group, that is node resource group. So I'll just show you how the Terraform is set up like that. So if I go and show you here, my Terraform code is actually setting up my cluster, and then you can see I'm setting up Redis public IPs and inside public IPs inside the node module. So node.rg is read, and then in that node.rg I'm setting that up. So yeah, you can do that, and then you can see I'm setting a domain label name. So what I have done is, if you go into Redis Insight here, you can see my IP is this one, public IP. I have used that IP in that YAML file I have shown you previously, but here is a DNS name. So using this DNS name, I can access the Redis Insights that I have deployed. So let's try to do that. So I'll go and say, and with the port 5540, I am accessing it. Now to allow this port 550, you might have to allow a NSG rule. So let me submit this, and then I will go back to networking setup here and show you how I have allowed Redis Insight port here. So you can set up a rule like this in your NSG, so that it is allowing 5540 port access from public. So because of that, we could access it here. And now why I'm saying it should not be available public is because of licensing terms if you are not doing open sourcing your project. But if you're open sourcing, no problem accessing it publicly. So maybe you want to set up internal routing and create a VPN. So let's try to, if I try to access a standalone mode, there'll be nothing because that is not there. But if I try to test the connectivity for this one, you should be able to see this is working. So you can see test connection is successful. And if I apply changes, you can see, let me go inside and come back outside maybe. And you can see it is a OSS cluster, and you can see all the modules are also loaded. So this is fully supporting everything. So I'll show you how it works as well, probably. So I don't have any keys defined yet, but I can do something like this. So probably I can, let's start with a simple key. Maybe I can just say set myself a user 1 as my key, and then I can set a value. Probably I can say Chaminder 001, and then I can set up even expiry directly here. So I can set as 10 minutes maybe, and then I can run this. So if I do this, it is accepted. So if I open it in another tab and show you, I'll give it a second to get it opened. And then if I go here, and you can see my user 1 is already there. And the JSON is really useful. So let's look at JSON data. So let's create JSON set, and then I will give a key. Maybe I'll say task or something, and then I'll say my task GUID or something -001. So I'm trying to represent a GUID here, and then where I'm storing it, I am storing it in the root path, and then I'll say I am setting the value as, and as I said, like this is expiring in 10 minutes. So you can see if I try to refresh, it is getting expired in 8 minutes now. So you can set an expiry, or you can not set an expiry and it will become permanently stored. So if you want to remove it, you have to set expiry, or you have to manually delete it. So let's set a JSON value here. So to set a JSON value, maybe I will try to do something with okay, I have to be using colon here to have proper JSON format. Maybe I'll say task ID is task 001 or something like that, and then I can say maybe status. Okay, make sure your JSON syntax is correct here, otherwise it will not work. So I will say status as maybe defined, and then I can say something, some other property, maybe file info or something, and then you may have so many other things you want to store, but I'm just putting some dummy things, info 1 or something. So you can have many details in a valid JSON format, and then when you execute this, it should create the JSON document inside the Redis. But the thing is, like, you can't directly at one call you can't set the expiry. You need to set expiry in a separate way. So let me show you how you can do it. First, let's create this. So you can see this is getting created, and then if I refresh it here, you can even filter by the types here, and you can even filter by patterns here. So you can just say task asterisk. So if I filter here, you can see only tasks are getting appeared. To create a second one, probably let's copy this one to make life easier. So I will make it 2 here, and then just make it 2 here for the task, and then maybe info is also 2, and then I will run this again, and you should see a second one also appearing if I'm trying. So you can see there's no time limit here. Now it is not going to get expired. So I'll take a third tab and show you some other interesting information as well very quickly. So you can see here it is having something like this. So if you go into this analysis, you can see you have data. So you can analyze all these available data, and you can get a database analysis report, and you can generate a report, and you can see things are getting expired and giving you how many bytes available after this is how many data will be cleaned up from that one, and then no expiry if there is anything. So you can see this is, you have 414 bytes as no expiry. So you can see this is 27207. So when these two together, it's 400 bytes in no expiry. Now, how to set the expiry for these kind of JSON things? You need to say expire, and then you have to provide the key. Now I will copy my key here quickly, and then once I copy the key, I can put it here, and then what I can do is I can put that key into here, and then I can say expiry is 600, that is for 10 minutes, and I can run this. So once I do that, I can see a response as this, and then if I go and refresh here, you can see now it is 9 minutes 50 seconds. So that is how you set it, and I will try to set the same value for the second one as well, just to give you the idea. Not the second one, the first one. So when I run it again, you can see it is running like this, and you can see it is if I refresh it, it's again also having a expiry now. Now you can see this is expiring in the 8 minutes, 7 minutes, the other one. So maybe I will try to show you how to do an update. So let me type JSON dot set, try to paste something. I don't want to do expire, but rather I want to update. Let's say if I want to update a JSON document partially, so I want to set only the status. So in that case, what I can do is I can do like this. So I can say $.status. So I have, okay, before that I probably copy this and okay, let me, instead of doing this, I can show you how to do a JSON get here. So if I do a JSON get with the key, I can see the values here. Alright, you can see the values defined here. So if I paste it again and then set the 1, and here I can use this workbench to, okay, I think I did something wrong. Okay, it's JSON set. Okay, I should be saying JSON get here. Get, and then I can run this, and you can see it is getting like this. So I have the 2 here, and then what I will do here is I will go and change this to 2, and then if I want to update the status, what I can do is $.status, and then I can do set the value. So value I want to set as double quotes processing. So I want to change this to processing. So if I want to do that, I can go ahead and do that, and then if I go here and try to see the task 2, you can see it is processing and it is in defined state. So likewise, you can partially even update the JSON document using JSON module of Redis. So that is, I'm showing you capabilities of Redis JSON, and there's even facilities to index certain things, certain fields. You can create indexes using this thing. So you can go and explore in Redis documentation about more how to use Redis. So you can see now we are accessing it inside the cluster, because my Redis inside pod here, Redis inside pod is inside the AKS cluster, and we are exposed that UI into us using public IP, but the connection is still inside the cluster. Now if I try to open my Visual Studio and I have a test created, and so let me try to open this up, and then this is a test code that I have created. So I will show you what happens if I try to access this from local code. So what I will do is instead of here, I will do a comment here, and then I will enable it as localhost. To do localhost access, what I will do is I will try to connect to Redis cluster here using this cluster IP. So what I will do is kubectl port forward, and what I will do is copy this service cluster, and I will say namespace is Redis, and I want port 6379. That is the port 6379. So if I do this, the expectation is, okay, my port forward is happened. Now local port 6379, I should be allowed to access the Redis cluster from source code as well. So let's try to do that step by step and see what will happen. Let's try to ping the Redis database, and then let's try to add a string key and see what will happen. Okay, I will create some breakpoints and I will run this. So when I do this, you should be able to see it is actually do some kind of connectivity, and it will be let's go and see the step by step, and then you will understand how it really works. So I came here now, so I will do a debugging, and I will try to show you what will happen. I will go to the next step. So you can see it is getting db, and then you can see if I try to ping, what will happen. Yeah, ping works fine. So you can see it is pinging in few milliseconds and it works fine. The ping works fine, but let's say what would happen if I try to add maybe I'll add another breakpoint here and see if I can get this through setting a string. Let's see what will happen. So it's immediately saying it cannot access it, and you can see it is trying to access internal IP addresses of the pods. So this is only available within the cluster. So this way, when you deploy a cluster, you won't be able to access it from the source code itself. So how can we solve this problem? So to solve this problem, what we can do is, okay, we can immediately see there's an error and we can't access it. Now if you just go and see what is this IP address, like it would be one of the IP addresses of this one. So you can easily verify that using cluster IP setup here. So if you go to services and ingress, you should see in the Redis namespace, if you go to Redis namespace, you will see a cluster IP called Redis cluster, and you can see all the pod IPs here. And if you go and see the pods, you can see the pod IPs are here. Now this particular error message is having 112.2.187. So that should be one of the pods, 187. That is replica 0, one of the masters. This is because we have multiple masters. It will try to access either one of these IPs, and that cannot be accessed from outside of AKS cluster. So you can't access a Redis cluster from outside of AKS or the Kubernetes environment. So for this purpose, we might have to deploy it in standalone mode. Okay, so let's quickly deploy it in standalone mode and verify if we can access it for local development, so that everything is complete for you to work with Redis in AKS. So I'll stop debugging here because there's no point trying to do this, and we can even try to use the same local host routing and show you first. So let me try to quickly deploy now the standalone mode Redis. So I'll keep the existing one. So I will just copy this out here, and I will paste it in a notepad, and I will do a replace to allow the syntax correctly in Linux. Copy here and okay, cancel and clear this. Why I'm doing this in a separate namespace is in a single namespace you can't do this, but in your realistic scenario you will be only having this in this standalone mode in your dev environment, and your production environment Kubernetes cluster or your QA environment Kubernetes cluster will have Redis cluster mode, not Redis standalone mode. But in your development environment you will have Redis dev mode or standalone mode. So let's deploy this very quickly. Since we have deployed Bitnami prerequisites and the credentials, this should come up very quickly with one master node and 2 replica nodes for it. So you can see here in the documentation itself, you see it's kubectl port forward and Redis dev. You can do Redis standalone master and you can easily access it. So we don't we can go and see like how it getting deployed. So maybe get all Redis dev. Let's see if it is ready. It's still pending, so it might take few moments. So while this is happening, I'll explain you another thing, that is to access this outside of your Redis AKS cluster. What you can do is you can define a load balancer. Again, when you are setting you can't do this with Nginx Ingress because you need to use a load balancer for this kind of purpose. But again, you can use an internal load balancer with a private IP, and then using your VPN connection only expose this for development for your organization's development team. So you can create Azure VPN and then enable that. But for this demo purpose, I am exposing it through a public IP again, and that public IP I have defined in here. So I will show you here Redis pip, and that public IP is having the value of this one, and I have created a DNS name for that one like this. So because of that, I can, in my code, I can access this after deploying this using this Redis AKS DNS name and with port 6379. Again, this 6379 port is allowed in my network settings here. So if I go to here, like I should have enabled 6379 port access in my NSD rule. So that's why I can access this. So, but you can actually do a port forward and do a localhost kind of access, but that is not that easy. So I always recommend you to use a private IP and internal load balancer, and ensure to expose it via VPN. Since it is out of scope to set up VPN in this demonstration, I'm using a public IP and public IP DNS name to expose it. So let's maybe create this one as well, so it's available for us. So I can say Redis dev here, and then I can click this one, and the load balancer should be created. So if I go here and check again Redis dev, now you can see it is running, and the load balancer or the replica is also getting created, and the load balancer is also created. So okay, you can see now it's all ready and running. The load balancer is also running. But before accessing it via load balancer, I will show you how to access with port forwarding, since I have mentioned it. Okay, we have a port forwarding here. Instead of now using Redis cluster, what I will be using is this service. Again, cluster IP service, and you can see here I'm changing this to this one, and then I change the namespace to Redis dev, and then I do a port forward. Now when I do this, and if I run my local development code, let's see what happens. Now this is in my local machine. I'm running this step by step, so you can see I can do a ping. So ping works fine, and ping is done in few milliseconds, and now I'm trying to set 2 keys. Let's see what happens with the 2 keys. Okay, it sets correctly. So we can go ahead and see if it is actually set in the Redis Insights. So I can go back to Redis Insight, and I can access this time the Redis standalone, and see inside Redis standalone, you already see I have this 2 stored. So before going further, I'll stop this debugging. This is not the best way to do it, but like let me try to go back here and try to enable that load balancer DNS name. So you can actually use it in using an internal route, internal private DNS zone hostname, and then have a VPN, and then connect it via private VPN so that you can expose it inside organization. So when you do that, or when for the demo purpose, when we have this DNS name, again it will allow us to easily use this for local development. So you can see if I ping, it should ping fine. Since I am setting the same key, it should not create anything new, but I'm setting up a JSON as well here. You can see I'm doing a JSON set, and I'm creating something, and then I'm updating the same thing. So what I'm doing is I'm creating this structure, and then I'm doing an update to here. So I'll at least try to put a breakpoint here before update, and then I will run this, and you should see I have created this one, this record. And then if I go here and try to refresh this, I should have JSON data now. You can see it is there, and then I will run the update step. So I will put a breakpoint here, and I will run the update, and then we should see this is as updated. And then when I go here and try to refresh this data, you can see it is updated. So this is how you can connect your Redis cluster with the local environment, and you can see expiry is set. So how we set expiry in the code is something like this for JSON data. So you have to do a second call expiry, and then for this one you can call directly when you're setting the string expiry. So when you're creating it, you are setting the expiry, and when you're updating it, you don't need to set expiry or anything, because it should work with the original expiry. And what I use for this one is, like, I'll complete this code running, and then I will go to the project and show you. I'm using latest version of Stack Exchange Redis for this purpose. So that is how the connectivity happens, and you can even go ahead and set up timeouts, etc. for this if you need it, I think inside cluster the 5-second timeout works totally fine, but if you want to increase, you can increase it to 30 seconds or a 15 second to be having a better thing. And then this one might be important as well, and you can set other settings. You can go ahead and read the documentation and improve the settings like this. So that's basically how you access it locally, and even for this standalone cluster you would get the same analysis reports, but it is not in cluster mode, so you can see again these details are available, but in your Redis cluster mode you can have, okay, we don't have any more data now, but I will try to create so you can see it's saying it doesn't have data, but you can execute the same thing to get a few data here. So once you have some data, this report becomes more interesting, and you can see which node it is getting stored. So you can see this is stored in one and this is stored in another. So two keys are stored in two nodes. This is working in a sharding mechanism. So your third one might get one of these nodes. So it works really nicely, and you can see it's really useful. So with this, I'll conclude the session, and I hope you have learned how to deploy it and how to use it for development purposes, as well as how to use it in cluster mode for production purposes, and bit about licensing terms. Again, read them thoroughly before you use it in your organization if you're using it. But if you're having open source code, no problem, go ahead and use it, because it should be free for open source usage anyway. So hope it was useful, and thank you for listening to me for some time. So let's conclude the session now. Thank you.